under 20 minutes, it takes much less time. Okay, so the limit of a constant as x approaches a. For example, here's the constant y equals 3. And here's a, whatever you want. What is the limit of 3 as x approaches 4? How much?
3.
That's it. So the limit of a constant equals the constant. Who cares where this is going? If the limit of a constant is still a constant. Okay, number 3. Limit now of a product as x approaches a from either side. Take a guess.
Does it equal the product of the
limits? Of course. Equals the limit of f of x times the limit of g of x as x approaches a from either side. Of course, assuming the assumptions are fulfilled, and then this will equal what? Savannah, what do you think?
Sorry, I was still writing down the second one.
That's okay.
I'm not sure.
Well, we know that this is L, right? And this is M. So this is L times M, right?
Oh.
That's it.
Okay.
That's all.
Oh.
That's all you can do. You cannot do anything else. Good. So let's say I'm on page 4. So number 4, limit of f of x divided by g of x as x approaches a. Again, take a guess.
Can you leave the last one on, please? I was just still writing.
Sure.
Would it be L divided by M?
I have to write the intermediate step, but you're correct. Eventually it will be L over M, correct. But I have to write the intermediate step first.
I'm good, thank you.
Sure. Thank you.
So, limit of f of x over the limit of g of x?
Very good. Of f of x as x approaches a, limit of g of x as x approaches a, and this is indeed L over M. However, there is a big if, which I did not say for any of the other ones. I didn't have an if here, I didn't have an if here, and I didn't have an if here. But why I have an if here? What for?
If m is 0.
If, say it again, if
m is 0.
Very good. Otherwise it's undefined. Very good. And the limit will not exist. Perfect. In this case, m cannot be 0. Okay, number 5. Limit of a constant times a function as x approaches a from either side. Anyone will give it a shot? What do you think? Anyone?
Wouldn't it just be the constant times the
Very-
limit of f of x?
Very good. And that will end up being Zainab, what do you think?
Would it be CL, C times L?
That's it. And number 6, limit of f of x, and f of x is raised to power n as x approaches a. Of course, n has to be a positive integer. Okay? So this will follow the following rule. And x approaches a. What is this equal to?
L to the power of n.
Good. And last one is the same thing with the root. So limit as x approaches a, the nth root of f of x same thing, will be the nth root of the limit of f of x as x approaches a. What is the inside?
L to the nth root.
The nth root of L. So of course n is a positive integer. Okay, positive integer. And now let's see how we apply all these. We already did one example with polynomials. And I would like to write one more theorem here, another theorem. The limit of a rational function I'm going to call it r of x is r of a. And you can say, is it the same with the polynomial? Yes. As long as this number is in its domain though. Here I didn't have to write an if or only if, because polynomials are defined everywhere. But here I have to write if and only if a, this number, is in the domain of r of x. Only if it is in the domain. If it is not in the domain, then I cannot plug it in. And now I would like to look at a few examples. And if you have your book, I don't need to show that yet because I don't have graphs at this moment. But I have my tablet ready. Please choose any problems from 9 through 36. 9 through 36, and the page is 113.
I have a question.
Yes?
So I wasn't really sure what the constant is. What is the constant?
What is the what? Say it again.
The constant in the
5, 10, 11, -3, -20, 10,000, 0, 1/2, 2/3, anything. As long as if it is in the domain. As long as it is in the domain, I can plug it in. Any constant. It has to be given to us, otherwise we don't know where to calculate the limit. So that has to be given to us. Okay, I'll start and then you choose. I think we're done with polynomials, so I will move on to the next ones. Okay, so
What
let's
page
look.
was it?
113. 113. So we'll start with 18 on page 113. So we have the limit as x approaches 3 from x squared minus 8 divided by x minus 2. When we calculate a limit algebraically, so let me just for a second remind you where we are. I'm still looking at the limit laws, but I'm also applying algebraic limits. I'm looking at algebraic limits using the limit laws now. In other words, I don't need to graph. I'm determining the limit algebraically. So we're working on these two together now. Okay, so what type of function is this? I mean, what type of function is it?
Is it quadratic?
Rational function. This is a rational function. And yes, we will look at 36 after that. When we get to that, sure. So 36 is not quadratic. It has a square root on top of it, so it cannot be a quadratic function, right? Haber, are you with me? You said 36, but 36 I see it has the square root. So it cannot be quadratic. Okay, good. So this is a rational function. whenever we calculate a limit algebraically, please remember the first step is plug it in. Every time I look at an algebraic or determine a limit algebraically, I have to plug it in. And now again you should say, wait a minute, you already told us that when we say that x approaches 3, we mean x does not equal 3. True. But I also have this theorem that says if you determine the limit of a rational function, plug it in as long as this number is in its domain. Is 3 in the domain of this function? What number is not in the domain of? Yes. What number is not 2? Indeed. So I'm going to plug it in. The numerator goes to what?
1.
Very good. The denominator goes to
1.
Good. So then the limit is
1.
So notice one, thank you, Jackson. So notice one thing. I dropped the limit operator because I applied it to the function. The moment I apply it, I drop it. So number 2, do not drop the limit operator until you apply it to get the final answer. You have to carry it all the way. Okay, before we get to 36, I would like to look at problems 19 through 30.
Is 1 the final answer?
I'm sorry?
Is 1 the final answer?
Can I continue with anything? Can I do anything to 1?
No, my question is like, normally when you get a rational function, you would have to state what it can't equal. So when we write the final
Very
answer,
good
we just
point.
say,
Very good point. We don't care as long as we are looking at 3. We're not near 2. We're at 3. It's a very good point you're making. Completely agree. But I don't care that x cannot be 2. Because the focus is at 3. So on the real line, here is 2 and here is 3. I don't care what happens at 2. I only care about what happens at 3. Very good point. Is that clear now?
yeah.
Perfect. Well done. Okay, so then I would like to look at 24. And I didn't forget, you chose 36. We'll get there. Can we do 36? Yes, 2 is out of the domain. 1, I'm not sure what that 2 and... Oh, okay. You were answering about something else. Okay, perfect. So then we have limit as x approaches -3 from 2x squared minus x minus 21. Everything divided by 9 minus x squared. What do I have to do first when I determine a limit algebraically? Plug it in. Yes, plug it in. So please plug it in and tell me what is the answer at the top, and plug it in and tell me the answer in the denominator. Gabby will give us the answer in the numerator, and Shvam will give us the answer in the denominator.
Is the denominator 0?
Very good, awesome. What about the numerator?
Do you want me to do that?
No, I said Gabby. Gabby, are you with us?
Yeah, is it 0?
Very possible. So 2 times 9 is 18. 18 minus 21 is -3 plus 3 is 0. Very good. So limits. I need time for this. Can have different situations. One of them is infinity. The other one is negative infinity. The other one is D and E. And the one that I left for last is called indeterminate. cases. There are 7 indeterminate cases. All these indeterminate cases, I will write above, have hope for the limit to exist. So here, no hope whatsoever. These will never exist. If the answer is infinity, negative infinity, or D and E, done. These have absolutely no hope. Limits do not exist. But if I get an indeterminate case like this one, I'm not saying that the limit exists. I'm only saying that there is hope. This has chances of existing. I may be able to get a number at the end from 0 over 0 or any other of the 6 indeterminate cases. But if I get any of these, it's done. Closed forever. So I see that 0 over 0 is hope, has hope. So the limit may exist. Can anyone give us the factored form of the numerator? And I would like to give you a little trick here. The little trick comes from the remainder and factor theorems. You may remember them from previous math courses or not. It's okay. Here's what I need you to understand. If I have a polynomial, p of x, divided by, let's say, x plus 2, the remainder of this division, if there is one, will be the numerator evaluated. So this has to be x minus a. So a is negative 2 in this case. P of negative 2. If I have a polynomial divided by x minus 3, the remainder will be p of what? Can anyone tell us?
3.
Exactly. Another example, just for you to understand what I'm trying to say. P of x divided by x plus 4, the remainder, and remember, this is always 1 in front. Always 1, and the degree, the power is always 1. Otherwise, if the power is not 1, the remainder and the factor theorem do not work. If the leading coefficient is different, we can use them. But we have some intermediate steps. So what is the remainder in this case?
Negative 4.
P of evaluated at negative 4. I take this, replace x by negative 2, and whatever number I get is the remainder. I take this, I replace x by 3, whatever I get is the remainder. What if the remainder is 0? What do I conclude for any of these? So I'm going to use a different color. This is a different question. If p of negative 2 is 0, then can anyone tell us what happens? What do you think? Then x plus 2 is a of p of x.
Factor.
Thank you very much. Thank you. We did that in college algebra, Alex. I'm sure you remember. Thank you. Exactly. So if the remainder is 0, then this is a factor of p of x. The same thing here. If p of 3 is 0, then x minus 3 is what for p of x?
Factor.
Very good. And so on and so forth. Same thing here. Same. X plus 4 will be a factor of P of X. Okay, what's all this? I spent 10 minutes on it. Why is this so important? Here's why. So if I plugged in -3, and I got 0 for both of them, what is the factor that I have to try to get rid of, as well as from the numerator as well as from the denominator? What is the factor? If I plug in x equals -3, that's what we did. When I plugged in -2, the factor was x plus 2. So what is the factor that must go away from the top and from the denominator for sure?
X plus 3.
Thank you very much. This is the factor. So when I continue here with the limit, do not drop the limit operator. As x approaches -3, I know one factor. I don't know the other yet. But I know one factor for sure. I can put it in blindly. Which factor again?
X plus 3.
Indeed. So this is half of the work. So now I know what factor goes in here. Of course, I will have to rearrange, put the negative in front, and x squared minus 9 for sure. So this will have a minus in front. I'm going to write it again if we need to. So what is the factor here and what is the factor here? So this is a huge leap forward by the fact that I already know which factor to expect. So the factoring process will be always easier.
For the bottom one, would the other factor be x minus 3?
Of course. Guaranteed. Great job. And what about the other factor in the numerator? It has to have 2x, right? Because only 2x times x will be 2x squared. And then what will I get from 3, whatever, to get -21, obviously?
Oh, sorry, I was muted. It would be 2x minus 7.
That's it. It has to work. Because when we plugged in -3, we got 0 over 0. So this factor now must go away. And as Rita said, she said, okay, you have to state that x does not equal -3. No. Not in this case. I have to state, if you want, that x is not 3, but now I don't care. Because everything happens around -3. There is no need to write this. This is implied by x approaches -3. For sure. We know x is not -3. It approaches -3, so there is no need to write that. So then I'm going to continue here. So continued. And I'm going to put this symbol, the equal symbol, and the circle, so you know where it's continued. So I'll copy limit, do not drop the limit operator, negative in front, 2x minus 7 over x minus 3. And now, what do we do next?
Plug in -3 again.
Excellent. I copy the negative in front. I drop the limit operator because I apply the limit to the function. Who would like to give us the top?
-13.
Very good. The numerator is -6 minus 7, -13. Well done. And the denominator?
-6.
Very good. How many negatives I see here?
Would it just be then 13 over 6?
How many negatives we see here?
Oh, sorry. Negative.
Very good.
13.
That's why I always take care of the sign first so I don't make an error. Please remember this. It will save you a lot of time.